Hi everyone, welcome to the video. Today we are going to solve shortest prime path. So in this question we are given two numbers, both of them are prime, okay? And we have to convert number 1 to number 2, okay? And there is a caveat that we will change only one digit at a time of number 1, only one digit at a time, and the successive number which is formed after changing one digit should be prime also. So initially we're starting with the prime number, ending on a prime number, and the successive number which are formed by changing one digit exactly at a time should also be a prime number. Okay, and we have to return the number of steps, number of changes which we accomplished in order to get the desired number 2 from number 1. Okay, so initially it may seem some integer or string problem, but no, this is a graph problem, shortest prime path. Each of them is a node, okay, and successive node which will be forming. Okay, so since it is shortest path, I will be using BFS algorithm for the same. See the time complexity. It is order of one, but you do not need to care about it. It is by mistake, I guess, and you will do normal solution. Okay, and see the constraint, it is thousand less than 10,000. So number one and number two both will be four digits. This will help us in reducing the complexity. So first of all, I will create a function is prime to check whether the number which we are forming is prime or not. We can also do one thing, that we create an array, and there we store all the prime numbers from between 1000 to 9999. Okay, so that we do not need to do computation for calculating prime and storing prime. We just store that prime, but that will be comparison of big array. So let's calculate it. And first of all, the base condition, if the number is 2 or 3, return 2, that this number is a prime, because 2 and 3 are prime. Now if number is less than equal to 1, or number is even, or number is divisible by 3, in this case it is not a prime, return false. So these are the base conditions. Again, for I in range, start with 5 because 2 and 3 already taken. 4 is not a prime, and ending will be, okay, yeah, the n into root of n plus 1, and I will take a step of sixth number, because see 2 and 3 are already taken. So 2 and 3, 6 is a multiple of them. Step of 6. This way we will reduce the complexity of calculating the prime number. Okay. Now if again n mod I is 0, or n mod I plus 2 is 0. Okay. In that case, we do not have reached a prime number, so return false, and again return true. So this was all about prime number. We calculated prime. Now we will check the first base condition in the main function, if num1 is equal to num2. If that is the case, we have reached a solution. We do not have need to return anything, return just 0. Okay, there may be some cases on that. So now I will store all the prime numbers. Initially they are false because everything is not prime in the first instance. Okay, now I will fill this prime array. Okay, for I in range, starting with 1000, going till 10,000. That's what we need to do, and append it. Prime I equals to is prime. Whether it is prime or not, it will get filled with the boolean value. If it is prime, this particular number, ith number is prime, then prime I will become bool true. If not, then it will be false. Now I will currently create a queue. Okay, with two numbers. The first number will be with a pair. The first number of the pair will be the current number which we are at, and then second number is the number of steps it has taken from the initial number one. So to begin with, we are taking num1 as the first number, which means we have not taken any number of steps. any, we have not done any changes in order to reach to number 2, hence 0, because we have not changed anything. It's just number 1 itself. Okay, again, an array not visited with initialization of true, which means this number has not been visited. If it were false, which we will do successively in the solution, which means this number has already been visited. But currently we are initializing with true everything, so it means this number is not visited yet. Okay, now we'll go through the queue. We'll check what we need to do. And since we are taking BFS, so we'll stub the element from the right side and we'll pop out the elements from the left side. Remember that. Okay. Q, 0th element, and Q dot pop. We are popping from the left side. For I in range 1 to 10. We will just, now what we'll do is, now we will take the number which we are at, current number, and what we will do, we will just change one digit at a time and check whether it is prime or not, if it is, well and good, we will succeed, we will just move ahead. If it's not, we will discard this number and change some other digit. Okay. Okay, now for in range 1 to 10, because number are between 1 to 10, it's 10, which means number will start from 1 and go up till 9, not 10. Okay. Now for j in range, but not in range, but in array, because that is what we will multiply. We have 4-digit number, so we will multiply these numbers with 10. Number in I with number in j. Okay, let's say the number in I is 2, then we will multiply, if it's the second digit, second last, we will multiply it by 10. So it will become 20 to get the what? Face value of it. Okay, now the next step, store a number which will store this temp0, which we took. Temp0 is what? The number which we are at, and the temp1 is what? The number of steps it has taken to transform from number 1 to the current number. Okay, so temp0 is the number which we are at after modifications. Now multiply it with I comma j, I into j, because that is what I mentioned you to get the place value. Okay, now if this temp0 mod into 10 greater than num mod into 10. Okay, here we are checking if this number is greater than, or what is it, greater than the number, and subtract it by j into 10, j into 10. Okay, because we do not need greater number. If prime, if this number is prime or not, we are checking the number which we have reached at, the number, this temp0 plus I into j. If this number is prime, return temp1. Temp1 is what? The number of steps we have taken from the initial number num1 to reach the current number. Okay, plus 1, plus 1, plus 1. Okay, if this number is prime, good. Now again I missed one condition. Okay, if this number is prime, then again if this num is same as num2, that should be the case. We have to check whether this number is same as num2. If that's the case, then we have reached the solution. If that's not the case, we will check if whether this number num is visited or not. Okay, if initially we have, what, initialized everything in not visited to true, which means this number is not visited. If this number is visited already there, then nothing to do. But if this number is not visited, which will return only true when this number is really not visited, we will replace it with false, which means this number got visited. And at the end, we will append this number. What? in the pair in Q, the first number is the number which we are at, which is num in our case, and what the number of steps we have taken to reach this. Number of steps is what? Temp1. Temp1 is what? Number of steps which we have taken so far, and plus one to add to it. That we have taken one more step. We have taken one more step to reach the solution. That will do our job. And the end, I will just return -1 so that if we are not able to reach to particular solution, this will yield -1, which we are not able to get number 2 from number 1, then it should give -1. Okay, which means we are not able to. So as you can see, this did our job. This did our job and passed all test cases in pretty less time. It took some time, but definitely this is not order of one complexity. Okay, so I hope you enjoyed it. Thank you. Have a nice day.